Hi everyone, so in this video I'm going to teach you a little bit about inverse normals. So an inverse normal distribution function is used when you know the probability and you need something else. So you may know the area under a curve and two of the three other variables in the distribution. Now, if you're looking for the x value, then it's simple and straightforward on your calculator, as we'll see in example 1. But if you need to know the mean or the standard deviation, then you're going to need to use a z-score. And just to refresh your memory, our z-score formula is z is equal to x minus the mean over the standard deviation. And just a reminder, all that does is tells you how many standard deviations above or below the mean your particular observation x is. So we're going to take a look at a few examples, as I had said. First example is going to be relatively straightforward. So example 1, given this distribution x, where it's distributed normally, it has a mean, remember that's our mean, of 10, and a standard deviation of 2, because it's always the square root of this. Recall that in this notation, that number is our variance. So we have to make sure to take the square root. And we're also given the fact that x is less than some value, gives us a probability of 0.7. We're asked to find that value. Now, because I have x is less than, I know that whatever my observed value is, I'm going to be considering the shaded area to the left, because that's all the region less than that particular portion. So I know that this area underneath this curve adds up to 0.7. That's what that statement tells me. I'm just simply asked to find x. Well, this is pretty straightforward. You're given the other two parameters. You're given the area under the curve. Let's go ahead and use our inverse normal function. So we'll press second function, vars, to pull up our distribution. We'll scroll down to, or we'll just press the number 3 to pull up the inverse normal. The area under the curve is 0.7. Now, our mean is 10. And I want you to note, on your calculator, it asks for the standard deviation. But in the distribution, it gives you the variance. So always make sure that you enter in the standard deviation. If this is a weird number, you can always just go ahead and type the square root of here. So I'll just do this in this case anyways, just to show you that it can be done. And let's go ahead and see what we get. So it'll give us our syntax. We'll just hit enter one more time. And we get an x value of 11.04. I'm going to round to 9. And I'm going to write from inverse norm. Now, if I were given all of the text in black, I would expect to see this diagram constructed, and I would also expect to see this value here. Although this would be a very straightforward question. Let's take a look at one that's perhaps less straightforward. Example 2. So here we're given a distribution x, and we're told that it's normal. We don't know the mean, but we do know the variance. And we know that the probability of x being greater than 30 is 0.6. So we're asked to find the mean. Now, I will immediately go ahead and draw a curve. And I'm drawing that curve as my normal distribution. Now I'm going to draw my center, and I'm going to indicate that that's where my mean is. And I don't know my mean, but I do know that there's 0.6 area under the curve above 30. So remember, there's half below the mean and half above the mean. So if the amount above 30 is 0.6, then that means 30 must be to the left, because 0.6 needs to be shaded to the right. So I'm going to guess that that would be a pretty good approximation of where x would equal 30 would exist. And this region to the right would make up 60% of the data. Now, one thing about the inverse norm function is it's left-tailed. So when you enter in an area inside that wizard, it's asking for the area of this left tail. Fortunately for us, that's just the complement area. So this complement area here, well, if this region is 60, then this region is 40. So we now know a little bit about this. We want to find kind of how many standard deviations below would be the upper bound for 40% of the data. Well, this is where we're going to need a z-score. So because we don't know one of these components inside here, it's a very good indicator that we're going to use a z-score. So I'm going to say the probability that z is greater than z is, sorry, I made a mistake there. I should say z is less than z is equal to 0.40. The reason why I made a mistake is, remember I just told you that it had to be left-tailed. So when I'm using the inverse norm and a standard normal distribution, I'm always going to have my inequality sign pointed back this way. And so I'm really frustrated by that error. But the probability that capital Z, the distribution, contains a random variable that's less than that observed value is 0.4. So I can go ahead and find that value. I'll do that using inverse norm on my calculator. Second function, vars, 3 for inverse norm. My area is 0.4 this time. My my mean is 0 because it's the standard normal distribution. Remember, Z is distributed normally with a mean of 0 and a variance of 1. So my variance and my standard deviation are both 1. I go ahead, I hit enter, and I come up with this value of negative 0.253347. So that is my value of Z that leads to that particular area. That means it's about a quarter of a standard deviation below the mean where I see that observed value. So that distance below the mean is about a quarter of a standard deviation. So a full standard deviation would be much further. Obviously, my diagram's not to scale. Now, it is useful to have this number saved in all of its digits. So I'm going to save it as a variable. See this stow button down here in the bottom left, right there? If I press that, it'll say answer arrow. And I'm just going to go ahead and store it by pressing alpha. And I like storing my Z values under alpha 2 because it's the character Z. So that means that Z is now going to be that. I'll show you how we'll use that in just a moment. So now we'll use our z-score formula. Remember, z is equal to the observed value minus the mean over the standard deviation. Well, the mean is the thing that I don't know. The observed value is 30, that value that I was given at the beginning. That observed value lines up with this particular z-score. So my z-score is negative 0.253. My x value is 30. My mean is still unknown. And my standard deviation is the square root of 100, or 10. Now I'll go ahead and rearrange and solve this. So I'll solve this for my mean. Now, I've saved this. It might have been useful to have it saved. I don't think it's particularly useful this time because I can just pull up the answer thing and multiply by 10. But I would do 10 times z, so 10z, minus 30, and that would give me negative mu. And so I just need to change this to a positive number. So this is going to be positive 32.53. So it seems as though my mean is going to be 32.53. And all of this logically makes good sense because my observed value is slightly below my mean. All right, that's example 2. Example 3. So again, I think you could have predicted what was coming next in that I was going to give you an example where I gave you an observed value, an area, a mean, and not the standard deviation, and then asked to find the standard deviation. So again, because I don't have one of these values, I know this is a really good indicator that I'm gonna need to use a z-score. So I'm just gonna go ahead and write down my z-score formula right now. And I may even start filling in some of the things that I know. So I know that my observed value is gonna be 20. I know that my mean is 15. I just don't happen to know what sigma is. And I'll leave z blank right now because I have no idea what it is. But I am gonna find it. So I'm dealing with a normal distribution. It's a great idea to go ahead and draw a normal curve. I'll indicate my mean at 15. And the probability that x is less than 20 is 0.62. So 20 would be somewhere over here. And that's gonna be the upper bound. So the probability that x is less than 20 is this probability underneath here. And that is 62%, or 0.62. And that's for x equals 20. So our goal now is to find the z value that yields that same area. Well, we do that using the inverse norm function. So we'll go back to second function vars, 3 for inverse norm. Our area is 0.62. And I already have my standard normal distribution up here. So my mean is 0 and my standard deviation is 1. Go ahead, I hit enter and I get 0.3054. So that tells me that my z value is 0.3054. Now I should make a little statement here. The probability that z is less than z is equal to 0.62 implies that z is equal to 0.3054. When you use the inverse normal, you don't have to define z as distributed with a 0, 1. That's assumed. But you should indicate that you've gotten your area using the inverse norm function. If I didn't do that on the last example, please make sure that you do that every time. So now I simply have this formula. It's a simple linear equation. I just have to solve it for sigma. So I'll multiply both sides by sigma and divide both sides by 0.354. And so I'll have 5 over 0.3054 rather. So 5 divided by that answer is equal to 16.367. All right. 368 if we're rounding to 3 decimal places. Now let's just do a quick check, right? Because we know that, this thing should have an observed value less than 20. We can do a check with our normal cumulative density function. So let's set the lower bound, because it's all the way down there, to a really, really, really large negative number, like negative 1 million. Now, I think there was already, there's way more zeros there than 1 million. But I'm setting it as a really, really negative number because it just goes infinitely on that direction. And I want to be really, really close to my final answer. Now for my upper bound is going to be 20. Now my mean was my given mean of 15. And my standard deviation is my calculated standard deviation, 16.368. So I'm really just checking my work now. I would expect that my answer that I should get would be about 62%. Let's see what I get. About 62%. So it turns out that this was the correct value of our standard deviation. Or, really, really, really close to like 6 decimal places. So I hope that this video clarified a few key points, and I'll recap those key points right now. Key points are inverse normals, which are found by second function vars and scrolling down to 3, are useful when you know the probability, when you need one of these other 3 components in the distribution, and if you need the mean or the standard deviation. That means you're going to have to use a z-score. And remember that z-score is just finding a multiple of the standard deviation that your observed value would be found at. Hope you enjoyed the video.